Example 2 asks us to find all 6 trig functions of, remember here, just theta, even though they're giving us 2 theta. So they want all 6 trig functions of theta, and they're giving us 2 theta. And the fact that our angle has to be between 180 and 270, meaning we are in quadrant what? Our angle theta is going to be somewhere in here. Quadrant 3. So when we are asked with finding all 6 trig functions of the angle theta again, and they don't give us anything about that, but they did tell us something about 2 theta, we just got to work backwards. Because ultimately what we want to be able to find and say is, what is this? Since it's to the left, negative angle. What is this? Which again is down, so negative. And what is this? The x, y, and r, again though, of theta. And since they told us 2 theta, then we can use this to try to rewrite it in terms of our theta and try to figure out any of these. Okay? So remember, the only ones that we need to find are actually those 3, because then we can just do the reciprocal to find these last 3. So even though they're asking us for all 6, in reality, you only need to find the first, or the big 3, I call them. Okay? So how are we going to do that? If you want to pause it here and try to figure that out, go for it. If not, I'll continue on with the explanation. So since I'm given cosine of 2 theta, I know since cosine of 2 theta, which they gave me is equal to negative 12/13, is identical to any 3. Remember, we came up with 3 identities. I'm going to choose the one of my preference and then work that out to find what it is in terms of just theta, not 2 theta. And so again, I'm going to go ahead and choose 2 cosine squared theta minus 1 is equal to that, so that I can work with positive things. I much prefer those to the alternative, which is 1 minus 2 sine squared theta. Okay, you can use the other one, which is cosine squared minus sine squared theta, but I'd rather not use 2 trig functions, because remember, I'm trying to find what it is for just theta, and I don't want 2 of them. Okay, so in reality, you only had 2 options to replace this, and I chose this one. If you want to try it for the sine squared one, go for it, and you should come up with the same answers at the end. It won't be the same for this because you'll have sine instead of cosine. But all of these, and therefore these, should come out the same. All right? So let's solve for cosine of theta. Not just theta, but cosine of theta, by undoing everything that's been done to it, starting by adding 1 to both sides. Now notice I wrote my 1 as a 1 over here because that's what I have, but I wrote the 1 over here as 13/13 because I'm going to have to add to this fraction. So what's left is 2 cosine squared theta on the left and 1/13 on the right. Next, I'm going to have to get rid of that multiplying by 2, so I'll go ahead and divide, which is the same as multiplying by 1/2. When I do that, the 2's cancel out, and I get cosine squared theta equals 1/26. My last step would then be to take the square root of both sides. And remember, if you take the square root, you have to include the possibility of it being a positive or a negative value, which we already know because we know what quadrant we're in. Okay? However, we're going to go ahead and take that square root to get cosine of theta, and then I'm going to go ahead and split it as the square root of 1 over the square root of 26, because I do know the square root of 1. So in this case, I will rewrite it as 1 over the square root of 26, which if I actually split that up into its factors, we know that's equal to 2 times 13, which no perfect square under there, so it does me no good to rewrite it. But they're not going to want that. So one thing that you can do right then and there, though, is because this is what cosine of theta is equal to, I'm going to go ahead and take this and I'm going to flip it to get my secant, which would just be the square root of 26. Okay, but I'm also then going to have to rewrite this by multiplying by my 1 once again as the square root of 26 over 26. And that then gives me my x's and r's, which I can then plug in up here. And if you'd rather use these, might be a little bit simpler. But now I have the cosine theta answer, which I could plug in over here. So the only thing left to do is to take this x, which I know is a 1, and take this r, which I know is the square root of 26, and then solve, which since there's a root involved, that is definitely not a Pythagorean triple. So remember, the r will always be the one by itself squared, and then the other 2 squared will be added together. So one of them is a -1, the other is a y value that we will find, and then the square root of 26. And when we square a square root, we'll have a pair, something squared, so it comes out the y squared plus 1, and then you can solve. And we get y is either 5 or -5. And we already said over here that it had to be negative because of the quadrant we are in. So I won't ever miss that fact, because some people will just take the square root of 25 and they'll say it's 5, and they'll forget that it could have been positive or negative. Okay, so now that we have everything in our nice visual picture graph here, we have our x, we have our y, and we have our r, then I should be able to come up with any and all of those. So that's it. Sine is equal to the y over r, which we know the y is this, our r is that. So I'm going to go ahead and do the reciprocal of that to find cosecant first. So that would be my r over the y. And remember, it was negative because of the quadrant. So cosine also would have been negative because of that x being that -1 here. Okay, so again, just be careful with your signs. Only ones that should have been positive were tangent and cotangent. Okay, so then sine would be the reciprocal of that, which would be our 5 over root 26. And so we'd have to multiply by the root 26 over root 26 one more time to get -5 root 26 over 26. And then tangent, one last time, do that work, and you would get y over the x, which would just be a +5. And if you flip that, 1/5 for cotangent. Okay, so what was the key to the whole problem, even though they gave us, and pay attention to the details, 2 theta, and they wanted all 6 trig functions of theta? It all came back to, once again, our graph. If we can get our graph with our triangle and our reference angle for all x, y, and r values, then we should be able to come up with any and all of these pretty simply. Okay? Pay attention to the details, be nice, neat, and organized. This shouldn't be too difficult. So moving on to example 3, they want us to change gears a little bit and go back to what we talked about earlier on, and that's verifying. Now, of course, they're going to be using the identities that we didn't know before when we were verifying. So hopefully you will recognize some of these. Okay? So the first thing that we're going to do is try to take, usually like we mentioned when we were verifying these in earlier sections, we're going to take the side that is more involved and try to simplify it to look like the other. And right away, hopefully you recognize that this is a double angle that they're trying to say is equal to that. Okay, so I'm going to take the left side and try to make it improve that it is indeed equal to the right side. If you want to pause it and try it on your own, go for it. Otherwise, check this out. hopefully you notice that this is the difference of two squares. The two squares would be our a to the fourth minus b to the fourth. Just trying to put it into more algebraic terms. And that would leave us with what squared and what squared. Well, it'd have to be an a squared and a b squared, so that we could rewrite this as a squared plus b squared times a squared minus b squared. But of course, we don't have a's and b's, unfortunately. This is trig. We're dealing with sines and cosines. Okay, so I'm going to rewrite that all as this same form, but with our a's and b's being cosine betas and sine betas. So that would yield my a term squared and my b term squared, like we discussed. Now at this point, hopefully you recognize more identities. It's not just going to be from this section, it's everything inclusive. And this right here should be popping out at you immediately as something really, really nice. Anytime you see squared terms, you should be thinking of Pythagorean. And remember, sine squared of an angle plus cosine squared of the same angle is always equal to 1. So we can literally just rewrite this whole thing as a 1. And we know 1 times this is that. And that right there is our first double angle identity that we came up with. It is cosine of 2 times our angle, which our angle in this one is beta. And that is exactly what they wanted us to verify or prove. Okay? So if you kept going with the algebra, notice that this is the difference of two squares again, and you got the cosine plus the sine, and then the cosine minus the sine. That's okay, but remember, with the verify problems, they're actually asking us to provide this answer. And since they already gave us that answer, keep that in mind, that what I'm looking to find is that, or a form of it. So don't keep factoring when you already have what you wanted. Okay? So try part B if you'd like. More algebra coming at you. Because we have something minus something squared, you should know that you have to take that and square it. Foil all of that out to see what you get. And hopefully then can simplify to be what they want. Okay? So go ahead and give that a shot. If not, here we go. So like I mentioned at the beginning, we're going to take the more difficult looking side and try to simplify it to the easier, simpler looking side. And so sometimes it'll just tell you what to do. I can't do anything with this because they're not squared. And remember, if you square it, you can't just square each piece, because when it has the whole quantity squared, it means that times itself. That's what that means, which means I'm going to have to FOIL and distribute this whole thing out. So that would yield cosine squared be the first thing of that angle, 2x. And then cosine 2x minus a sine 2x multiplied together would be a negative sine 2x cosine 2x. But when I do it again here, I still get that negative sine 2x cosine 2x. So I said I had 2 of those negative sine 2x cosine 2x's. And then lastly, a negative times negative is positive. Sine 2x times sine 2x is again sine squared of 2x. Now, obviously, that does not look like what we wanted it to look like yet. But anytime you see squared terms, as long as the angles are the same, if I have the sine squared of 2x plus cosine squared of 2x, I know those together equal 1. So all I have is 1 minus 2 sine of the angle 2x, cosine of the angle 2x. And again, I know this one's new, but hopefully you recognize that as our double angle formula for sine. So I can rewrite that as 1 minus this whole thing is the double angle formula for sine, which means I will take sine and do 2 times the angle that is already there. And the angle that is already there is 2x. Don't forget to double it. Just because it's already there doesn't mean you just put 1 minus the sine of 2x. How else should you know that you may have forgotten it? Look what they gave us and asked us to find. So now that I have all of that, I have come up with 1 minus this all multiplied together, which would be my angle for sine, would be 4x, which is exactly what I was tasked with verifying or proving, that those two things are indeed equivalent. Okay? Hopefully you're able to do that. Not too much difficulty. You can see why it would pay to memorize as many of these identities as you can. And you can do them all. It's just a matter of, are you going to put in the time and the effort? Okay? Because if you don't, you're going to have to keep flipping back to notes and trying to see, is this one? Is that one? When can I use it? When can I not? So do yourself a favor. Memorize these so that you can use them and get through these problems as quickly and as simply as possible. So here is our fourth and final example for this section of double angles, and they want us to simplify the expressions, but they may not give us exactly what we need or want. They may look very similar, but they may not be exact what we want. So we may have to get creative. So do me a favor on this one, please. If you haven't or haven't been doing this regularly, please pause it right here and try to come up with each and every one of these. They do progress in difficulty, I will warn you on that. Part A is pretty easy, B is about a medium, and then C is a little bit harder. So pause it, see if you can do all three, and then I'll come back and explain each and every one. All right. Hopefully you gave those a shot. Like I said, they do increase in difficulty, but part A, very, very basic. Hopefully you recognized, and I highly advise you to put parentheses around our angle so that you don't make a mistake and put the -1 in with it, because that looks like our 2 cosine squared of our angle minus 1, which is a double angle formula for cosine. So I can just write 2 times whatever my angle is, and they gave us an angle of 5x. So the answer to that one was simply cosine of 10x. If you want to keep the parentheses around it for your argument, your angle, it's perfectly fine. Feel free to do so. Now the next one, if you tried that one, again, I hope you did, was not too bad, but it wasn't exactly what we wanted. This does also look like a double angle formula. Go figure. It's in the double angle section. However, when you get to the quizzes and tests, they're all going to be mixed in. You're going to have to start recognizing these, which is why I advise you to memorize them. This is missing something. I want it to look like 2 sine of an angle, cosine of an angle, because that is my double angle formula. And notice I have the angle that is the same, but I'm missing the 2. So can I take what they gave me and just multiply it by 2? Can I make it twice as big? Unfortunately not. But what is one thing that we can multiply by that does not change what they gave me, but possibly the look of it? Hopefully you got my hint. It is a 1. So if I want a 2 there, what else would I have to multiply by in order to make it a 1? Well, that would be what is called its reciprocal, because we know that half of 2 is 1, and 1 times that will stay that. I'm going to rewrite this as 1/2 times 2 times my sine of 165 degrees cosine of 165 degrees. So hopefully you can see I still have exactly what they originally gave me. And then this right here is just a funny looking 1. But what I'm actually going to do is group these things together, because that then is my double angle formula. But don't lose that 1/2 out in front. That has to be there. So now what I would have would be 1/2 times this, which I can rewrite as a double angle for sine. So that's going to be the sine of 160 doubled is 320, and 5 doubled is 10. So that would be the sine of 330. Again, 2 times the 165. But they asked us to simplify, not just make it look simpler, which we definitely did make it look simpler so far. But we should recognize that 330 degrees is one of our reference angles. That is 360 less 30. So don't forget what quadrant you'd be in and whether it be positive or negative, which we know it would definitely be negative. And then since this is a reference angle of 30 to go all the way around 330 degrees, we know the sine of 30 is also 1/2. But because it's 330, we know it's going to be negative. So our final answer for this one, multiplying straight across, don't lose your negative, would be negative 1/4. If you got that, very well done. That was a little tricky by multiplying it by that. Some people will just get this and then they'll say the answer is negative 1/2. When in reality, they had to have that extra 1/2 out in front so that you multiplied by that fancy one and did not change what you had, even though that 2 is what you needed. Okay? So if you want to pause and even try part C and challenge yourself, go for it. If not, let's do this last one here, and then you guys can go and practice all of these types of problems on your own. All right, so hopefully you notice that we have our tangent of our angle, and then 1 minus tangent squared of our angle. We actually wanted that 2 right up there. If that 2 was up there, then we would have exactly what we wanted. It would be our double angle formula for tangent. But of course, they're trying to test you. I want the 2 there, but I can't just multiply by a 2. I'm also going to have to multiply by that 1/2 again. So hopefully you can see this fancy 1 that I multiplied by. And then I'm just going to rewrite it to look a little bit different. So as you can see, I did multiply by that 1, but I'm going to take the 2 and the tangent 34 and I'm going to keep them together. And then I'm going to take the stuff that I don't want, this 1/4. Be careful, it is a 1/4 and not a 4. And I'm going to write that out in front, which is being multiplied to all of this. Because all of that together is my double angle formula for tangent. So that would allow me to then rewrite it as my 1/4 that I still have out in front. And then I got the 2 tangent 34 over 1 minus tan squared of 34, which is the double angle formula for tangent. And so just like the last one, we'll try to simplify that, and that would give me 1/4 times, that would now be the tangent of 68. And is 68 something that we can simplify and make nice without using our calculator and getting some big long decimal representation? Not 68. If it was 60, then yes. So therefore, I will put that over 1, multiply straight across to get my final answer in one big fraction to be the tangent of 68 over 4. If you want to leave it like this, that would have been fine as well. Okay? So again, be very careful, nice, neat, and organized. Pay attention to your signs and where you're located. And then memorizing all those reference angles from the very beginning of the class, as well as all of our new and previous identities. Okay? Wish you all the best of luck doing these on your own. It's going to take some practice for sure. Don't be afraid if you make mistakes. Just redo it. Find where you're making those mistakes and try to clean it up to not make them again in the future. Take care, everyone. See you at the next video.